VRAM, Video Memory, Intermediate Level, GPU Memory System. Introduction. When working with graphics, large amounts of data must be processed quickly, including images, textures, video frames, 3D models. To handle this efficiently, GPUs use a special type of memory called VRAM, Video Random Access Memory. At the intermediate level, understanding VRAM means learning how GPU memory works, how VRAM differs from system RAM, how VRAM affects performance, how data flows between GPU and memory. What is VRAM? VRAM is a type of memory dedicated to the GPU for storing graphical data. In simple terms, VRAM equals memory used by the GPU to process graphics. Example concept. Graphics data means stored in VRAM means processed by GPU. Why VRAM is important. Graphics processing requires handling large data sets quickly. Example concept. High-resolution graphics means more data, means need faster memory. Without sufficient VRAM, textures may not load properly. Performance drops. Games may lag. VRAM versus RAM. Feature RAM VRAM. Used by CPU, GPU. Purpose, general tasks. Graphics processing. Speed, fast. Optimized for graphics. Location, system memory, GPU memory. Example concept. RAM means CPU tasks. VRAM means GPU tasks. What VRAM stores? VRAM stores different types of graphical data. Frame buffer stores the image being displayed. Textures, surface details of objects. Shaders, programs that control rendering. Geometry data, 3D models and shapes. Example concept. Textures plus frames plus models means stored in VRAM. How VRAM works. GPU, VRAM, means display output GPU. VRAM means display output. Step by step. Data loaded into VRAM. GPU processes data. Frame generated. Output sent to display. VRAM capacity. VRAM size affects how much data can be stored. Example, 4 GB means basic gaming, 8 GB means modern gaming, and 12 GB plus means high-end workloads. Example concept. More VRAM means handle larger graphics data, VRAM bandwidth. Bandwidth determines how fast data moves between GPU and VRAM. Bandwidth equals data transfer speed. Bandwidth equals data transfer speed. Higher bandwidth means better performance. Types of VRAM. GDDR, graphics DDR, commonly used in GPUs. High-speed memory. HBM, high bandwidth memory, very high performance, used in high-end GPUs. Example concept. GDDR means common, HBM means high-end performance, VRAM and resolution. Higher resolution requires more VRAM. Examples. 1080p means moderate VRAM. 1440p means higher VRAM. 4K means very high VRAM. Example concept. Higher resolution means more VRAM needed. VRAM bottlenecks. If VRAM is insufficient, textures load slowly, frame drops occur, stuttering happens. Example concept. Low VRAM means performance issues, shared memory, iGPU case. Integrated GPUs do not have dedicated VRAM. Example concept. iGPU means uses system RAM as VRAM, real-world example. Playing a game. Game loads textures, means stored in VRAM. GPU processes means renders frames. Display shows output. Advantages of VRAM. Advantages include fast access to graphics data, improved rendering performance, smooth gameplay and visuals, efficient GPU processing. Example concept. More VRAM means smoother graphics, limitations. Challenges include limited capacity, expensive in high amounts, cannot be upgraded easily in most GPUs. Example concept. High VRAM means higher cost, concepts learned. What VRAM is? Difference between RAM and VRAM. How VRAM works with GPU. VRAM capacity and bandwidth. Performance impact. Simple definition. VRAM, video memory. a specialized memory used by the GPU to store and process graphical data efficiently. Final summary: VRAM is essential for handling graphics and visual data in modern computing systems. It stores textures, frames, and models, allowing the GPU to process them quickly and render images efficiently. The amount and speed of VRAM significantly affect performance, especially in gaming, video editing, and AI applications. Understanding VRAM helps explain graphics performance, system requirements, and GPU efficiency.